Perfect. Welcome everyone to Cloud Data Driven Online User Group Meeting. For today's webinar, I will be your host. I will introduce myself and also introduce the speaker um, in a few minutes. First, let me tell you a little bit about our community. Cloud Data Driven fall under Data Driven community, and under this community, we also have Feature Data Driven. Feature Data Driven is one of the largest online free event related to data, AI, and visualizations. In terms of AI, we cover all layers: machine learning, deep learning, generative AI, along with Copilot. For this year, Feature Data Driven have a couple surprise for you. Not only networking, free content, we also receive a big support for Redgate. Not only he's one of our sponsors, he's also willing to give away 3 free tickets, right? To go to PAS Data Community Summit in Seattle, which is going to be this November. So this is free. It's a big saving. We highly suggest you to register for Feature Data Driven, right? And then attend the live session. During the live session, we will share with you a QR code and a link for you to access and participate to that raffle. So once you're in there, you don't have to be present. As long as you join any session, you uh, subscribe to that raffle, which is the link we will share with you, you should be good. And Redgate will keep you posted if you are one of the winners, right? And then to register, we normally have about 2,000 people live with us. Let me see if I can bring this. To register, all you have to do is to access data-driven community. There is a registration, so I will share that link with you. Once you click on these registrations, right, you first have to confirm to make sure that email is valid. So after you hit submit, okay, that you will have an email confirmations. Once you confirm, that's mean you are registered. And after that, you still have to join the live session for you to have access to the URL that will allow you to participate to Redgate. Yeah. So, and then on the Cloud Data Driven, this is where we are. We meet every Thursday at 12 p.m. EDT or New York time. We have a tons of other session lined up, so we highly suggest you to go and register, right? Remember that, okay? Under this community, if you would like to know exactly um, uh, who maintain it, the primary person is Ronan. Even though I'm the founder, I have to be honest with you, he is the engine behind the scene. The second engine person is Dipsy. I can't even express how much work she's doing. She's improving the way we're doing things, and she's working very close with Ronan. And I would like to say special thanks to them. Who am I? Okay. I am Jean Joseph. I am the founder and the co-organizer for this community. The intent of creating this community was to give it back. Okay. And right now, I am a freelancer, but I used to work for Microsoft as a technical trainer, mainly focused on data and AI and visualizations. So for now, I am only open for contract or consultant work or even training work. If you happen to have any need related to any project, like when it comes to data, AI, and visualizations, even training, feel free to reach out to me and I will be happy to work with you. So in total, this is who we are. I'm the founder, and the second co-organizer, Ronan, is the head of everything. Uh, and then Zipti is the moderator. So as you know, we have Francisco. Francisco is a professor, a data scientist, okay, consultant, and he's also a co-founder of Cubisco, if I can pronounce it right. And Francisco, listen, it is a pleasure to have you today, and I cannot wait to learn with you. And I would like to say special thanks to all attendees for sharing your time with us. Francisco, if you don't mind, feel free to share your screen, introduce yourself, and start with the presentations. Thank you. It's a pleasure to have you all.
Thank you, Jean. And again, welcome to all the attendees and thank you for being here. I hope my audio works well. I will now immediately share my screen and just for a very quick introduction because we want to go immediately into business. But I think it's good that you know 1 minute who you're dealing with or something about me, but very, very quick. So let me share the screen. Okay, so the first thing is Cubisco, it's a corporation. I don't want to spend too much time on that, but if you want information about Cubisco, this is the website. We do consultancies, of course, on Power BI especially, but not only, data management in general, also strategic things and forecasting statistics and so forth. But again, that's more than enough for our purposes. What I'm mostly interested more is to show you our LinkedIn page. Is the LinkedIn page of Cubisco again. So you find us at LinkedIn/Cubisco, because you see here that every 2 weeks we publish a DAX challenge, which I prepare personally. It's a very demanding task, one challenge every 2 weeks. There is a question, this is your task, we give you the data, we explain you the problem, we give you a deadline, and then after some time we publish the solution. And the solution is published, has been published yesterday, and there is this video showing myself, sorry for the volume, you see showing myself how to solve the problem that was outlined into the challenge. So you want to test yourself or make sure you understand DAX or see how much you can do in DAX and improve. It's totally free. I think it's a good opportunity. It's done in English and Italian, so if you're not a native speaker, the text is in English and the video is anyway, for the solution, is anyway in English. And we do also some follow-up questions after that. Here you see the discussion. There is a first question now, like, why is this code not working? Now, don't get scared. We're not getting into code of this complexity in this session, but I just wanted to tell you that that's a free resource that, of course, you can consider in case you want to keep up with your DAX skills. Now, we will discuss DAX pillars. By DAX pillars, I mean DAX fundamentals. And of course, we need to do something practical. We don't want to give you an idea of DAX like theory. So we need to do some theory because otherwise we don't understand why we get some errors sometimes. But after we do the theory, and we will do the theory here in a whiteboard, so it's interactive and we can just discuss very quickly, we will go into Power BI to apply what we learn. Now, this is a very simple Power BI file. We didn't expect you to be using your Power BI file. It's a too short session to allow for interaction. So I will just click here and there and just write DAX code. We will try to understand why we have errors sometimes, why it works some other times, through the definition of these DAX pillars. Now, I took data from a typical Microsoft data set called Contoso. If you deal with Power BI, you surely heard this name. And here is the data model, very quickly. It's just a very simple star schema, nothing fancy. And therefore, our result will be very neat results. The point is simply understanding how DAX formulas work. And therefore, what we want to show you is what are the basic rules to be sure that we understand DAX and that we do not get surprises when we try a formula, not only in the fact that it works or not, but also on the calculation itself that it does. Because when the formula doesn't work, who cares? But if the formula works, is it doing what we expect it to do or not? So that's a critical part. Okay, so the idea is going through, we said, the DAX pillars. Now, in reality, I will list all of them, but there will be one that we will not go through, simply because it's a pretty advanced subject, and it's also counterintuitive at the beginning. And so for the purpose of this session, I will list all of them. I will just leave out of the discussion, maybe we can briefly discuss at the end of the session, the last one. So what are these DAX pillars? Let's say the fundamentals, the foundations of DAX that we need to understand in order to assure that we know what we're doing and we don't get errors in the formulas. Now, I don't know what is your opinion. For questions, I forgot to say this. For questions, you can use the chat, and Jean will be so happy as to remind me if I didn't, let's say, notice a question, so we can answer that as soon as possible. We will have a Q&A discussion, of course, at the end. Now, I will start with a very strong statement. DAX is a simple language. I know that this will maybe cause you some pain, because you might say, how can it be so simple? It looks like a very complex language, but I insist on that. DAX is very simple. The problem is that usually what we need to do is complex, and since DAX is powerful, we can do powerful stuff, but again, the language itself is simple. And it is so simple that its pillars are just a very short list. Let me give you this list. First, row context. That will be our first task. Second, filter context. Third, iterators. Fourth, context transition. I hope we can make it to get to the context transition today. I will be necessarily not going too deep in each of the subject, otherwise we will need 1 week. But the fifth one, which is the one that we will not go through, is expanded tables. Nevertheless, you are free to ask questions at the end of the session also on that. Maybe you already know that and you want me to address something. So you see that the list of the foundations, it's a pretty short list. So basically, when you write a DAX expression, you need to consider that if you don't know at least these first 4 pillars, you're getting into trouble very quickly. Now, what is DAX? Well, DAX is the language that Tabular understands. It's the underlying columnar database in Power BI Desktop. It's a fantastic database in terms of performances for analysis. It's probably the fastest in the world at the moment. Now, why do we need these rules? For doing what with DAX? So what we can do with DAX? What can we create with a DAX expression? Now, with a DAX expression, we can generate measures. We can generate calculated columns. And we can generate calculated tables. Now, we can also generate our row level security filters, but let's say that that's something we don't want to cover today. And anyway, the rules that we're doing are valid also for that part. So these are the things, the objects that you can create with a DAX expression, with a DAX sentence, let's say. And we will see that understanding these pillars is critical exactly for this purpose. We will see immediately a first example. We will see that a code that works in a calculated column probably doesn't in a measure. And a DAX code that gives in a measure what we expect might give us something that we don't expect in a calculated column. So basically, this is where we will be playing with. We will play with measures, we will play with calculated columns, and we will try to understand why we get errors sometimes and the real meaning of what we are calculating. The calculated tables, I'm not sure we will need them. It might be we want to consider also some example of that based also on your feedback. So please give feedbacks even only through the chat. If it's not clear, if something is getting confusing, please feel free to interact. I would like to have an interactive session so that we can somehow get a good sense and a good value out of what I'm teaching you. Okay, so let's go straight to Power BI. Now, let's start, we said, with the row context. But instead of defining the context, let's create one of the three objects we described, and let's see that we will be forced to define this context. The object that is more linked to the row context is the calculated column. So in order to show you the result of a calculated column, I prefer to go into the table view. Because in the table view, we generate a measure, we generate a column and we see immediately the result. For measures, you will see me going here because a measure is not a column, therefore it doesn't have any value to show here. A measure creates values only on a visual. But let's go to where we belong. We said we want to generate a new column. Okay, so I go to the sales table. This is what we call a fact table in business intelligence. Now let's take a look at this table. We have one row for each sale, of course, and for each sale there is a product, there is an order, there is a customer, there is a territory, and there is an order number, a line number, and then quantity and price. Okay, so first idea that could come to our mind is, I want to create a column in which I multiply order quantity by unit price. We can call that column sales amount. Okay, very quickly, we just want to create a column. Now we can click on this button here. I prefer to go here and select new column, but that doesn't matter. When I do this, Power BI is saying, hey, okay, give me the name of this column and then give me the DAX expression of this column, right? Like what we do in Excel, with a strong difference that this is not Excel. Even though you will see some similarities sometimes between the formulas, we don't want to confuse DAX with the Excel formulas. So we call it sales amount. Let's call it sales amount column, because we will try to do the same also in a measure. So that's just a name. Okay. So in Excel, we would type, let's say, B2 star C2 and B3 star C3 going down. This is a database, so no row numbers and no letter to identify the rows. So we write this expression that might sound obvious, but in reality, it isn't. Let's say that my definition of sales amount is the product between price and quantity. So what I type is unit price multiplied order quantity. Now, this apparently innocent expression already hides something to discuss. Let's click enter. And I get my sales amount calculation. You see the column is immediately filled, so everything is correctly working. No big deal. That feels like Power BI and DAX are easy. It's just as simple as writing this formula. Good. It is so easy that we might feel encouraged to take the same code. You see, I'm really copying the same code. I will include also the name of the object. And now I want to create a measure with the same code. So let's go here. The measure is a KPI, you know. I hope you're familiar with the concept of measures. So I just go here and I want to generate a measure. And you see, I've just grouped the colors. I would like to see the amount of sales for each color. I have the column, but I was said that measures exist. Let's create a measure. Again, we go here, new measure. The same editor opens. I can pass this. Of course, I want to write sales amount to measure to make the difference. But you see that, I already see that there is something wrong here. You cannot find the named unit price. How is it possible you cannot find it? It's right here, but it doesn't find it. So if we try to run this formula, we get an error. So you see that the first, we immediately have an issue. The same formula works in a column. I show you the result again. This is the result. It works perfectly. These are the values. But I get an error as soon as I want to create a column. Now, why is that? Now, let's define the first point that we need to define in order to understand what is happening. Now, when I create a calculated column, the DAX expression that I write is interpreted in a context of a current row. The DAX code is evaluated in a row context. What is this row context? Again, I'm speaking about a calculated column. The row context is the current row, is the existence of a current row in a set of rows. So think about a calculated column. You, by definition, need to go onto a table to create a calculated column. A table is made of several rows. Think about in Excel terms. You write the formula here, and then you do the double click to propagate the calculation down, right? Double click, the calculation is done everywhere. So the calculation is first done in a single row, and then if you want, you can expand this calculation in every row. This process is automatic in Power BI. We don't need to ask for that. And it should intuitively tell you that also in Power BI, a column is evaluated row by row in a table. The process of going row by row in a table is called iteration. So whenever you create a calculated column, again, you need to be on a given table. You must be on a table before you define that. Your code will be evaluated one row at a time. This row, and then this row, and then this row. So we have a current row that moves down, let's say. This is the row context. So we have many rows, but we go to one row at a time to evaluate the DAX code. So we evaluate that in a context of a single row. Single doesn't mean that the other rows are invisible. Single means that currently we are on a one specific row. That's what we call row context. And the row context is created for free when you create a calculated column. So in other words, you create a calculated column like we did, Power BI will create a row context on the table. Therefore, it goes one row at a time, and in one row at a time, which is at a time is the row context, evaluates the formula. Let's go back here and interpret why this is important. Well, it is important because by definition, I will tell you that this formula should not work. Why shouldn't it work? Because these are not two numbers. These are two columns. And nobody can multiply by them two columns. We can multiply two numbers. Forget physics and vectors. I mean, we are in BI here. So how is it possible that I don't get an error when I ask to multiply one column by another? The answer is the row context. If you consider that this formula highlighted is evaluated one row at a time, well, let's consider that we are in this row. In this row, order quantity is 1 and unit price is this number. A column is a set of values, but in a single row, a column has a unique value. And therefore, the software doesn't complain because it takes these two numbers and produces this number. Then you go to another row. The process works for every row. This is now the row context. And now it grabs these two numbers to provide this number. Now, don't worry that the numbers are the same. If you go down, you see the numbers do change. And again, same concept. In a single row, I can multiply the value of each column because it's a unique value. So this is what makes this formula work. I will type it for clarity. This is a calculated column. So a row context exists on the sales table, which is the table on which we are. This ensures, let me go back to the column. This ensures that this is a number, a single number, and this is a single number, and the formula works nicely. Now, let's go back to the problem we had with the measure. When we type the same formula in a measure, we have an error. And now it is saying a single value for the column unit price cannot be determined. Now, it would complain also of the other one, but it's already complaining about the first one, so it doesn't bother to tell you that it has the same problem here. Now, the problem here is that now we are generating another kind of object, which is not a column. We are not creating a calculated column anymore. We are now creating a measure. A measure is totally another thing. A measure is not a column, so is not a list of values for every row in a table. Therefore, it is not automatically generating a row context. So when you generate a column, you go row by row on the table on which you generate that. Good. But when you create a measure, are you on a specific table? You are not. When you generate a measure, you need to consider the entire data model on your back. So you can have access to any table. We have 5 here, we could have 20. Therefore, since the measure works with the entire data set, there is no row context given for free. So in a measure, you don't have any row context, at least not for free. In a column, in a calculated column, it is for free and it's automatically created. In a measure, you have no row context. Why is that? Well, on which table should I iterate? The software doesn't know that. And forget that we are using sales here, because when you learn DAX in complex ways, you will understand that there is not enough. The real truth is that I'm not on a specific table. I'm sitting on top of the entire model. So the software is complaining this time that, yes, I'm asking to multiply one column by another column. And this is not possible. That's why it says a single value could not be determined. So this is a measure, and no row context exists for free in a measure. We will see that for free we have something else, but not the row context. So the reason why this is not working is that I'm asking to multiply things that do not represent single number anymore, because they are not interpreted in a context of a single row. So what is the context then that applies to a measure? We have already seen that for a column, the context is the row context. Good, row context for free. We don't even need to ask for it. It's generated freely for us. Okay, what do we have if we have anything for free in a measure? We have a filter context.
Francesco, you did allow me to stop you for questions, right?
Yes.
We have one.
Good. What question is that? Can I see that in the chat? Yes.
No, I can read it for you though. It is it says, I'm not clear on you, sorry, on your use of term for free.
Oh, for free. Sorry, I'm Italian, so maybe it's not exactly what I should read. But let's say automatically created without us to ask for that. Okay, so for free, I mean, I do that, I create a column and the row context is there. In a measure, I don't have that. I can create it, but it's not for free in the sense that I need to ask for it. For me, that is a cost. I mean, I need to do something. That's what I meant. I hope it is clear now. And regarding Jill's question, the answer is correct. What you're saying, I will get back in a moment to that point. Jill said, maybe we need to aggregate the column values such as sum in a measure. And that is correct. I will get to the point exactly now. Thanks for the questions. Now, going back to business, we have automatically, I don't want to say for free anymore, automatically in a measure, a context of filters. So what is this filter context? Now, in order to show this, let's try to create a measure that works. So we will go back on that later. Does not work. Let's create one measure that works, and let's use it in our visual. And as Gil was suggesting, maybe the point is, let's say, total quantity. This is a measure. We need to aggregate. I will have to explain that in a moment. Now, we said that we cannot write something like this. If I say that this is equal to sales order quantity, I get again an error. Why is that? Because again, I have no row context in a measure. So the software is saying, what do you mean equal to order quantity? Order quantity is a column. Which one do you want? Now, how can I turn a column into a single value? Well, doing this is a set of values. If I want to generate one out of it, I can just do a sum out of it, if these are numbers. And so the total maybe is 50. This is a single value, and so the software will not complain anymore. So we don't want to have the value of one value. I say whatever values you have, sum all of them up and give me the result. That will work. I'm not asking now for the value of order quantity. That would be impossible in absence of row context. I'm just saying, please, sum all the order quantities together and give me the result. So I'm not going into each single value. So you see, it stops complaining. We use this column, this calculation, and we get this result. Now, my point is, it might be obvious to you now that this works. But now my question is, why do I get different values for every color? I mean, at the end, the order quantity is 60,398 in total. Why don't I read always 60,398? And I see a different value in every row of the visual. Well, that's because every row of the visual represents a filter. And a measure works nicely and naturally with filters. So how is this number calculated? Now, this number must be the result of this calculation. And why is the result this one and not this one? Because there is a filter on the color for the value black. How do you generate filters? Well, the moment in which you group a column in a visual, I grouped by color, and the measure is the calculation. So I asked Power BI to generate the list of the colors, and then for each color to calculate my measure. And when I say for each color, I mean after filtering for that specific color, I want to see the result of total quantity. So the reason why we get a different result every time is that every time we have different rows underneath the calculation. And let me show you how we can really understand this. Let's create another calculation, another measure, which is, please, I want to get the number of sales rows. Let's say equal to 1 at the moment. Let's inspect the sales table. If you go to the sales table, you will see that its number of rows is 60,398. Good. Now I say My measure disappeared. We create it again. Number of sales rows. We have a nice function in DAX, which is count rows, sales. I want to calculate the number of rows of the sales table. Oh, at the end, it was already there then. Good. I thought that disappeared. So the measure is here. And we type count rows sales. Now, what number do you expect? I would expect 60,398. But if you put it in, again, you see a different number in every row. It's identical because basically the quantity is always 1. But we can get something similar. Let's do, well, that's okay. Let's consider just quantity for the moment. So this result is nothing than, let me show the other formula. Here. This result comes out of the application of this formula to a column that only shows 1 on 9,843 rows. This result is the same formula, but on 28,000 rows that show ones, because the column again is just ones. So in other words, we see a different sales table every time. You see that the number of rows of the sales table is different. How is that possible? The sales table has 60,000 rows. That's not exactly correct in DAX. A table is always the table based on the filters. So whenever you create a visual and you group a column, not only you are asking to generate the list of the values of this column, which is here, but the moment in which you include a calculation, Power BI will filter one value at a time for that column. So these two calculations are done under the filter color equals black. And therefore, only 9,843 rows are visible. And if you sum all the ones in that subset of the rows, you get the total. Therefore, when you work with a measure, this is a measure. So no row context is given automatically. We don't want to say anymore for free, but you have a filter context automatically. So the measure code is executed after filters have been applied. And therefore, we say that a measure code is executed in a context of filters. How can we see these filters? Let's go to the model. The column color belongs to the table product. In the line of the report in which the color was black, this column is filtered for the value black. Therefore, I only see the rows of this table in which this is true. But these two tables are connected through a column named product key, which is a primary key in this table, and it's a foreign key in this table. So the filter on black in the color will cross-filter the product key. We didn't filter the product key directly, but imagine you are in an Excel file. If you select in a column of a table, color equals black, and you go to the product key column, I hope we agree you don't see all the products. You will see just the product keys that have the property of having the color equal to black. Let's say that these product keys are product key 1, product key 2, and a few other product keys, and whatever we want. Now, this connection, this relationship, you see there is a direction, propagates the filter applied on the one side to the many side. Therefore, this filter will apply to this table. So when we are under the visual, under black as the value for color, we only see the rows of the product table in which the product has a black color, and we only see the rows of the sales table in which the product key is one product key that in the product table has black as a color. And that means that this 9,843 rows are the rows in which the product is a product key that has black as a color. And therefore, we see a result different in every row for the number of rows of the table and the number of rows and the total sales quantity, right? Because this formula, even though they are the same in all these calculations, the formula are always those two. But the results are always different because each evaluation of these measures is done under a different filter context. Now, before stopping with checking whether you have questions on that, let's check what happens if we apply these formulas now back to a column. Where do we have a filter context in a column? We know we have a row context there, and we know that in a measure we don't have it, but we have the filter context. So going back to the column, do I have a filter context in a column or not? Let's try. Let's go back into a calculated column, and we create a column here, which is number of rows column, and the code is again the same, count rows sales. Now, when I first typed this again, this is a column, okay? So we have a row context on sales, which is the table on which I am. So what will happen? Let's think about how I define that. We said this code will be evaluated one row at a time. Now we know that this table is 60,398 rows. So my expectations, let's say 14 years ago, there was no Power BI then, it was just Power Pivot. I would expect that the formula count row sales would result into 1, 1, 1, 1. But I was wrong. Let's see the result. The result is the same number everywhere. I was very confused at the time when I get this result. But if you think about it carefully, it's totally correct. It's the question we're asking which is weird. Why should we ask in every row of a table, what is the number of rows of that table? The answer is pretty weird. The result looks weird too, but in reality, it's a simple result. If you are in the first row of a table and you are given the question, how many rows do you have in this table? You are in the first row, but you will observe all the other rows. And therefore, the answer is in the first row, 60,398. And if you go to the second row, you get the same result, and so forth for all the rows. So we get the same number here in every row. Why don't we have a different value? The point is that when we are in one row, in the sense of a row context, it is not the only row visible. That would be a filter. I said that is the current row in which I'm evaluating the code. That's totally different than saying that that's the only visible row in a table. So when you have a row context, you are going row by row in a table. The current row is not the only row you see. It's the current row in which you are evaluating this code or whatever code of a calculated column. So being in a row, iterating one row is not filtering one row. Therefore, there is no filter here. And why is there no filter in a calculated column? In a calculated column, we have an empty filter context. What do I mean by empty filter context? Now, let's look at each other 1 second. Consider what a filter does. A filter reduces the rows visible, right? It's a restriction. So if you have an empty filter context, it means you have no filters. If you have no filters, it's not that you don't see anything, you see everything. So in a calculated column, you have no filters at all. And therefore, this sales table, oh, sorry, I need to share again. I was saying that since we don't have any filter in a table, this expression is always showing the entire table, and the result in every row is 60,398. Back to the measure. Why does the same code in a measure gives me a different result? Because in a measure, we have filters. So this table has this number of rows when we are here, this number of rows when we are here, because these are filters applied to the model before the measure is evaluated. So you create filters in two ways in DAX, generating a visual and grouping a column. So this is the action to generate filters. Grouping one column. I take product color, I generate the list of values, and as soon as I add my measure, each of these values is applied to that column, product color, as a filter. The filter propagates from the dimension. You should always filter dimensions through the connection to the fact table. Filters, cross-filters that fact table too. Once this propagation is completed, now the code of the measure works. Finding, in this situation where we have black, a table with 9,843 rows and not 60,000 rows. So that's the reason why we get different results in the two cases. So just to do a first summary, we have discussed two different kinds of objects in Power BI. A measure has a filter context and doesn't have any row context. A column has a row context on the table on which you generate that, and there's an empty filter context. You can say it doesn't have any filter context, if you will. It's a bit loose language, but that's okay. We want to learn from the basics. Okay, so now let's try anyway to compensate from some lack of, is there any another question? People always tell me you have no filters. Okay, of course, that's another story, but thanks, a very nice, that's a nice one. Okay, so now let's go back to Power BI and try to compensate for some of these issues. What is this, just to complete what I said before, is there any other way to generate filters? Yes, with DAX language using a function we don't have time to look here, which is calculate. So you generate filters in Power BI in two ways. Either on a visual, you group columns and you generate a set of filters. Of course, you can group by multiple columns. And then the filter is a multiple filter. It's called a set of tuples. Now, I don't want to go into too technical jargon, so let's forget that. But for example, in this cell, we have two filters now. And that's what the filter context is. A filter context is a set of filters. How many filters do we have here? Color, black, and English education, bachelor's. Now we have two filters. We have a filter context with two filters. So that was just an example. Okay, let's go back now to the fact that the first measure we wrote didn't work. Here. And one of you, somebody that must be that already works in Power BI, said, yeah, this doesn't work because maybe you need to aggregate. And I agree on that. But it's not that we want to aggregate a single column. If I try sum, that doesn't work. So we start the iterator part. It doesn't work anyway. And that's because, prepare for a big bomb now, sum does not exist. Sum is not a DAX function. DAX is just a short for a more complex DAX function that is called SUMX. Therefore, if I write the sentence in this way, it looks complex maybe, but I will try to explain it in a minute.
You are not sharing. Francesco.
Oh, God, thank you very much, and sorry for this. So I was saying that the formula doesn't work if I leave it like this. But if I wrap this and I show that with a simple sum, I don't solve because I said sum doesn't exist. It's just an apparent function, syntax sugar function for something more complex. I can just type something like this to make the formula work. Now, it might look complex, but in reality, it's a very simple statement. Let me just justify one thing, and then we do an example in 3 minutes that will clarify everything. Now it is not complaining anymore. So no row context exists. But if the measure is now working, because it is working, I will now put it into action into my matrix. You see that now the formula works. Still, the formula performs unit price per order quantity. Before, we said that this cannot work in a measure, but now it is working. You see that the formula is working. How is it possible that this formula that needs a row context is now working into a measure where there is no row context? That's because this function called SUMX is what we call an iterator. And what are iterators? Iterators are functions that create a row context on a given table. So it is true that in a measure we don't have no row context for free, or we said automatically, but we can create one if we want. We need to specify the table on which we want to create it, because again, we are in a measure, therefore we need to say on which table we want to go, because we have all the tables at our disposal. So we need to specify where we want to go, but we can do that. So to complete, yes, in a measure, you don't have a row context automatically, but you can generate it. And in order to generate that, you need to call a function called iterators. Conversely, and then we need to justify this formula, in a calculated column, we said there is no filter context. Can I inject filters in a calculated column? Yes, through calculate. We don't have time to go through that. Okay, so now I try to explain in a very simple way this expression that maybe looks, whoa, what is this SUMX thing? And then a table, and then this. Now let's try to demystify what I just wrote. And then we have just a few minutes for a short view of the context transition, and then we go to questions. Now, suppose that you are given this table, a very simple table. Quantity, unit price. Quantity 5, I said unit price, please. Thank you very much, Microsoft. Quantity 5, unit price 10. Quantity 10, unit price 3. Quantity 20, unit price 2. And suppose that I ask you to describe me how you would calculate the total revenue, because this is quantity unit price, that this table is bringing. Now, I hope you agree that the answer would be, without Excel, Power BI, nothing. The answer would be, well, I need to go row by row in this table. In each row, calculate price multiply quantity. Go to the other row. Go to the other row. So that's what we calculate row by row. And then, if we sum the result, we get a single number, which is, by the way, 120. And this is the total revenue. We said, go row by row on a table. Let's start writing the DAX code. Go row by row is this. On a given table, let's call this table sales. So create a row context on sales. Now, what do you want to do in every row? Because here we have a row context now. We want to do sales order quantity multiplied by sales unit price. I'm doing what I was explaining here. And what do we need to do when we are done with this calculation? We said we want to sum the result. Very good. This is what I just wrote, and I will show it. Here it is. So here, now we have a row context in sales generated by SumX. So SumX is an iterator, so it generates row context. So in a measure, you can have a row context, but it's not automatic. You need to ask for it. If there is any questions on that, I would take the question now.
You have one question saying, is there a complete list of activators functions for DAX?
I can't understand that.
Do
Is
you
there a
have
complete?
any?
Yes. Yeah. Well, not exactly, but we can start something. So let me share. I will give you some instructions. Now, the iterators are all the functions that end with the X are all iterators. But there are, of course, functions that do not end in X and are iterators anyway, like add columns and add or filter. There is a funny story about filter, but I don't think we have the time to do that. So any function that ends with X is an iterator, and then add columns, filter, and a few other functions. But the best way to check this is DAX guide. You must know the Italians. I'm Italian too, but I'm not the Italian. I hope I will become someday, but Marco Russo was my maestro. They, for every function, they specify whether or not they are iterators. Let me show you this in practice. We go to DAX guide. I stopped by mistake, so let me reconnect that. If you go to DAX guide, and you go to any function, like for example, SumX, search SumX, iterator. Okay, so you know where to look for in order to make sure you understand whether a function is an iterator or not. Okay, so now the final thing, context transition, which usually requires something like 4 hours lectures. I will try to explain that in something like 4 minutes. Let's see what we can do with it. Let's go back to our column. And now, let's pretend that we want to do a calculation that should give us practically always the same result. Let's go to customer. We go to customer. This is another table. I create a column. I call it customer amount. And that is just go row by row. I hope you understand this formula now. On the sales table, in every row, do price multiply quantity. And please sum up the result. If I do this, I get always the same number. This should be clear now. The row of the customer in which I am is not a filter. It's just an iterated row, so it doesn't filter anything. And if it doesn't filter anything, the customer table is complete. There is nothing to propagate, so the sales table is complete, which means that in every row, I see the entire sales table, and therefore my amount is the total amount, because there I have no filters. Okay, good. But that means that with such a huge and powerful language, I can't create a column in which I can see the sales of that bloody customer. That's ridiculous, right? In fact, we can. If we want to inject the currently iterated row and turn it into a filter, this becomes the transition from one row context, because we are in a calculated column. So this is row context, but I want it to become a filter context. So I want this to become a filter, this customer only. If I can do that, this will flow from the row of the customer table to the customer rows in sales. And that will bring me to see the sales of that unique customer. Now, in order to do that, you need to write this calculus statement out of the expression. And now we see a different number everywhere. And this number is the number of the sales, is the sales amount for that customer. Let me prove this to you. 11003. We see this value here. Let's see if we find it here. 11003. 11003. The total amount is this number. Forget the slicing by color. The total amount is this number, which is the same number that I read in this cell. Now, the final touch is that, incredibly, this works also if I put just the measure. Okay, not this one that doesn't work, but yes, at the end, this is the one that does work, sorry, because now I fix the code, so it's not good to call it sales amount, it doesn't work. Now it's sales amount measure, okay, so we don't get confused. If I go back here, look, sales amount measure gives me the same result. Now, this should really be a bad thing. What is the code of sales amount measure? Here, but there is no bloody calculate here. So how is it possible that if I call this measure that has this code, let's do it here, and then we are done. So I write this code, and I get the same result everywhere. Okay, now I call a measure whose code is exactly that one. I get a different result. That is because every time you call a measure, this is automatically translated into calculate measure. And now you understand the point. That means that in reality, I'm executing calculate sum x sales, blah, blah, blah. So be careful every time you call a measure. There is a calculate statement on top of that. So calculate should be really something that you understand. You need to understand that and consider that calculate, among the many things that it does, transforms a row context into a filter context. In this case, the important point is that the current value of the customer key column in the current row becomes a filter for that customer. And since this is a table of customers, and this is a primary key, this means that there is only one row visible. This becomes a filter on this table. And the filter on this table will propagate to sales. And therefore, when in the calculated column, I ask to go row by row on that table, I only see the rows of that customer. This is what we call context transition. The transition from a row context to an equivalent filter context. Okay, as I said, we did not have time to go through the expanded table thing. If you're interested, you can request to generate another webinar in which we go a little deeper, slowly into the context transition, and we can also go through the expanded table thing. But these are basically the foundations of DAX. I will repeat them, and then I go to questions. The foundations for DAX, the ones that you absolutely need to know, are these first four. From 1 to 4. Oh, I need to go home. It's too late. It's 7 p.m. here, so I already worked. Apologies. So the four things that absolutely you need to know are these four. Of course, when you become expert, it's good also to know that foundation, but don't exaggerate. If you just master this, you already are in a very good position. Now, let's go to questions. Thanks for the hats off to the SQL BI Italians. I will bring the message to Marco later with a message. Now, I could reference the unit price from the product table instead of the sales table. Now, there is no unit price in the product table. In the product table, we didn't have that column. But if the question is, can I take from the sales table, when I iterate the sales table, the price in the product table, like it was a list price? Yes, you can. You need to use the keyword related. Related is like vertical lookup. You don't need to do that, a real vertical lookup, so the price will stay in the product table, but you can go in a row of the sales table. For every row in the sales table, many sides, there is only one row in the product table, one side, so you can fetch the list price from the product table. So if that is the question, the answer is yes. And then would love a session plan or advanced DAX. That's good. If many of you will ask for that, maybe the organization will decide for doing that. I understand also Adam's observation. I don't know where to find a list of iterators. It's not available. If you go in Microsoft documentation, it just shows you some examples, but there is not a full list. But believe me, it is not a problem in the sense that every time you need to use a new function, you need to check its syntax. If you do that in the DAX guide and not in Microsoft documentation, which is good for other things, you will immediately know if it's an iterator or not. I understand the point. Unfortunately, it was not provided yet, something which you click and you say, this is the complete list of iterators, or maybe, no, I was trying to check whether in reality there is something that all attributes, iterator. But I don't see, if I go on search, no, it doesn't generate the list. So I hope that I was wrong. I was not sharing again for the last time, sorry, so I will check it immediately. I was navigating the DAX guide page. You have this iterator thing that you can select. But if you click on search, I don't see the table list, the function list. So it's not available. I'm sorry for that. Anyway, of course, it would be good to have it. Yeah, Adam, I understand you. That's a good one as well. They do their best, but not always they are exactly perfect. But we love them also maybe for this reason. Okay, so any other question? Thank you. Yeah, I agree absolutely, Adam. Thank you very much for attending. I just want to give you my email in the chat so you can give a feedback, of course, not to me, but the organization. But if you have questions regarding what I showed, why don't you send me an email? We can, of course, interact. It's a nice world. I love being in touch with people that are outside Italy. DAX is my work, and therefore you find also myself on LinkedIn, of course. Francesco Bergamaschi, which is complex to pronounce for English native language people, but if you type it like that in LinkedIn, you immediately find me, and it will be a pleasure for me to connect with you. Okay, so I don't know if Jean wants to conclude with some words, but for me, let's say that the session should be over, and I hope that anyway, it was a valuable session.
Of course it was. And thank you so much for putting this together. I learned so much from it, and you can see the feedback from the attendees, the level of engagement. Thank you all for your participation. And I will also remind you to register for feature data driven. And if you would like to participate in one for a free ticket to go to pass. Now, this is the right time. Feel free to scan this, register, and join to participate to this raffle because Redgate is offering 3 free tickets for Pass Data Community in Seattle, which is coming this November. One more time, this session is recorded and will be available to our YouTube channel, okay? And if you would like to sign up for our upcoming webinar, feel free to scan this. You want to connect with us on Facebook. Those are the QR code. You are free to take a screenshot and keep it and even share it. Why not? And thank you so much. If you can help us advertise the feature data driven, that would be great. Like I said, every year we have about 2,000 or over 2,000 attendees join us, and we would love you to be part of this as well. And this is going to be our fifth years. One more time, thank you, Francisco, and thank you to all attendees. I will stop the recording. You are free to stay on the call, or you are free to end the call, because I'm pretty sure Francisco is done with the presentations. Am I correct, Francisco?
Correct. Thank you very
Oh,
much. I will run back home. Thank
mhm.
you and see you.
Thank
Bye.
you all.
Bye.
Bye.
Bye.